Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we will be looking at this problem that you can see on the screen. It is 2.27 from the chapter 2, that is units and measurements. Okay, from 11th standard, from the NCERT book, definitely. Okay, so let's solve this problem. It's one of the easiest problem that you can get. Okay, so the problem reads like this: estimate the average mass density of a sodium atom. Okay, average mass density of a sodium atom, assuming its size to be about 2.5 angstrom unit. Okay, so few data is given. First of all, let's note this over here. Okay, so first of all, radius has been given over here. Okay, radius has been given, that is the size is 2.5 angstrom units. Okay, and 1 angstrom unit is nothing but 10 raised to minus 10 meters. So it is 2.5 into 10 raised to minus 10 meters. Okay, so in this way now we know the radius is equal to 2.5 into 10 raised to minus 10 meters. Let's highlight this. Okay, yes, now we have to find out the average mass density of sodium atom. Okay, that means we have to estimate it, approximate value we have to find out. So we know the formula for density. It is nothing but mass per unit volume. Okay, mass per unit volume. So that means what we have to do is, first of all, we have to find out the mass of the sodium atom and divide it by the volume of that atom. Okay, volume of sodium atom. Okay, so it's a very simple problem. Okay, so let's read it further. Use the known values of Avogadro's number and the atomic mass of the sodium. Compare it with the density of the sodium in its crystalline phase, that is 970 kg per meter cube. Are the two densities of the same order of magnitude? If so, why? Okay, so that is our question right now, and we have to answer this question over here. Okay, so let's do this. This is going to be fun. This is simple actually. Okay, so first of all, they are saying we have to use this Avogadro's number. Now what is Avogadro's number? It is Na equal to 6.022 into 10 raised to 23. Okay, this is the Avogadro's numbers. Okay, when we say this, that means what? 1 mole of any substance. Okay, 1 mole of any substance, whatever may be the substance, it may be sodium, nitrogen, oxygen, gold, whatever you call it. Okay, 1 mole of any substance is equal to 6.022 into 10 raised to 23 atoms of that substance. Okay, 1 mole of any substance contains these many number of atoms. Okay, so let's highlight this. This is a very important relation over here. Okay, yes, here it is. Now also we have to use the atomic mass of the sodium. Okay, we have to use the atomic mass of the sodium. First of all, you must know over here that the mass number, okay, mass number, that is denoted by A, is equal to 23 for sodium. Okay, whenever we write sodium, we write it like this: 11, 23. Okay, 11 is the number of protons and number of neutrons are 12, so the total mass number is 23. Okay, that is the property of the sodium nucleus over here. Okay, this is sodium or atom actually. Okay, so this is your sodium. Now when we say it is 23, that also means that 1 mole of sodium, okay, 1 mole of sodium is equal to 23 gram. Okay, when the mass number of some element is 23, then 1 mole of that substance is equal to 23. Okay, this is actually a general relation. Okay, this is a very general relation actually. What do I mean by this? I will tell you. See, suppose if I talk about, let's say, oxygen is 816, right? So 1 mole of oxygen, Okay, see here, look at this. Mass number is 16. So 1 mole of oxygen 816 is equal to 16 gram. If I talk about, for example, let's say copper. Copper is here 2963. Yeah. So 1 mole of copper 2963 is equal to 63 gram. This is a very general relation. Then if I talk about, let's say, yes, uranium, for example, it's 236.92. Okay, so 1 mole of this element 236 here is equal to 236 gram. Okay, so this is a very general relation. Actually, we know 1 mole is equal to 6.022 into 10 raised to minus, plus 23 atoms. Okay, so this number has been devised in such a way that the mass number becomes its actual mass in gram. Okay, this has been devised in such a way that the mass number itself becomes its mass in grams actually. Okay, in grams actually. Okay, so that is a good thing for us, so that we don't have to remember the masses. Okay, I mean, this is very simple now. You just know this, and that's the mass in grams. That's it. How simple is it? When I say it's 16 or 63 or 236, it's not exactly, it may be a little bit less, like 15.999, something like this, 62.99, something like that, 236 or 35.99 or something like that. It's not exactly every time. Only the carbon, okay, only carbon has exact value. Carbon is 612. Okay, so A is how much? 12. So 1 mole of carbon 12 is exactly equal to 12 gram. So this is our reference actually. This carbon 12 is used as a reference for us. Okay, so this is the only element with exact value. Otherwise, all other are not exactly equal to the mass number into grams. Okay, so carbon is the one. Anyways, now we will move here. Okay, now we want to find out the mass density, right? Mass per unit volume. So what we will do is, see, we have got one number. 1 mole of sodium is equal to 23 grams. That means mass of 1 mole of sodium is equal to 23 gram. Now 1 mole is equal to how much? It is nothing but 6.022 into 10 raised to 23 atoms of sodium. Okay, atoms of sodium is equal to 23 gram. Okay, or we can say mass of these many number of atoms of sodium is equal to how much? 23 grams. Okay, so let's keep it in a box. Okay, now let's call this number as M. Okay, this is 23 grams. Now let's convert this gram into kg first. So it will be 10 raised to minus 3 kg over here. So this is the mass right now. Okay, now we want the volume. We have got the mass for 1 mole of sodium atom. Okay, sodium substance. Okay, 1 mole of sodium substance, we have got the mass. Now we will find out the volume for 1 mole of sodium. Okay, so let's do this.